galaxies, and then every so often galaxies will exude two quasars at the poles. These quasars start off very, very highly redshifted, and you can often see physical connections between the quasars and their kind of parent or their mother galaxy. These quasars, as they travel away from the mother galaxy, their redshift changes. It gets lower and lower and lower. It gets to about it gets to a certain point, z equals 0.3, and then you start to see these quasars moving back towards the mother galaxy. What he was able to show with these quasars, even though they're very highly redshifted and should, according to the standard model, be very, very far away and moving incredibly high speeds, are actually physically connected to much closer objects. So I think it was NGC 4319, I think, is one of his famous ones, when he showed this galaxy, which is about 100 billion light years away.
Well, that's beyond the observational horizon of the universe, bearing in mind that we're only supposed to come into existence 31.8 billion years ago.
Well, yeah, then we could, yeah, okay, again, we're talking about intrinsic redshift.
Yeah, what does that mean though? So I'm asking, do I have an intrinsic redshift?
Well, I'm not qualified to say whether you have an intrinsic redshift.
No, what I'm saying is, what's the physics behind this so-called intrinsic redshift?
Well,
the Hubble constant is basically redshift has been measured, and the Hubble constant sort of says that it's due to the expansion of the universe.
Yeah, which is,
and basically
that's the interpretation put on the Hubble constant.
Yeah, exactly. Yeah. It's an interpretation, whereas it doesn't actually work. So we know because of quasars that they're in front of galaxies and they have a higher redshift. So what that is saying is the fact that objects with a high redshift are younger.
Yeah. And
so the Milky Way is not moving towards us, it's just older because it has a blue shift.
The Andromeda Galaxy, you mean?
Sorry?
You mean the Andromeda Galaxy?
Yeah, that's yeah. Because it says that the conventional model sort of says that the Andromeda Galaxy will swallow us up, and is actually moving towards us. But of course, it's not, because that is guesswork built on the redshift idea that redshift equals velocity and speed. Even in fact, what it's actually showing is the Andromeda Galaxy is actually older than our galaxy, and our galaxy might actually be from the actual Andromeda Galaxy, as it's our closest. So our galaxy might have been born out of the Andromeda Galaxy because it has a blue shift. It actually goes the other way.
So the older something is, the bluer the shift. That's what you're saying.
Yeah, that's right.
But hardly any objects. In fact, the only objects known to show blue shift in the universe, as far as I know, are within the local group of galaxies.
That's right. Exactly. Oh. So this is, so we only go by what we can see. We don't make guesses as such. We just go by what we.
Okay, but that implies then that members of the local group are the oldest things in the universe, and everything else outside is younger.
Oh, according to
only if you're taking what Horton Arp says as being the whole truth and nothing.
And if
like a complete
is the only
description. What he was saying was that the intrinsic redshift is a factor. So there's the movement. He didn't try to disprove or contradict the idea that redshift can be a measure of things distance and speed, but also it was an and, not a but, if you like. Intrinsic, I've got you the reference right there.
Okay.
And to be fair, Horton Arp was much more qualified to tell you about it than I am. But the idea is that you've got these quasars that standard cosmology say, because of their redshift, must be incredibly far away and incredibly bright and moving away at incredible speed. He was able to point out that there are quasars that are directly and physically connected to their parent galaxy. Those parent galaxies are very much closer and have a very different redshift. So you've got two or three, if you like, objects that are very close to each other. The two, let's say, daughter quasars and the mother galaxy. The mother galaxy and the daughter quasars are all physically connected, all approximately the same distance away, given astronomical distances, approximately the same distance away, but have very different redshifts. So redshift cannot be only a measure of distance and recession. And it's there for you.
Okay.